Can you see my screen?
Not yet, actually. I think some trouble with last week. So maybe you can send.
Really?
Send.
You cannot see my screen?
Yeah, no. We
Oh
cannot
my
see
god.
the screen. Yeah,
Okay.
it's going. It's going. Yes.
Can?
Yeah, we can see
All
your
right.
slide.
Okay,
Yeah,
let me try.
yeah, clear.
Clear. Okay. Uh, okay. Can you see?
Yes.
Okay. So good evening, everyone. Assalamualaikum. So today this is our second lectures on instruments, data, and methods. Okay, so first thing, fishing methods. So in Malaysia, fishing methods practice include spinning, floating, purseines, gill netting, and hook and line. So among all of these methods, we only use purseines, gill net, and hook and line are the most commonly used. So the trawlers and purseines contribute more than 75% of the total marine catch, and the rest of the catches from traditional gears. For example, in tuna fisheries, the purseines and trawlers catches 95% of neritic tuna, and the rest by traditional gears such as trolling and hook and lines. So for purseines method, purseines ni dalam bahasa Melayu kita panggil dia pukat jerut. Okay, so school of fish are caught by means of a large net which surrounds the school. So the net is then pursed when the purse line closes the bottom of the net, after which the net is gradually brought aboard. So the fish are then lifted out of the net using mechanical grabs. The purseines fisheries use drifting fish aggregations device. Kalau nampak ada float line dekat atas tu, yang warna orange tu, so that's what we call it as fish aggregation device. So typically, these are bamboo rafts under where the fish tend to congregate, and they may be monitored remotely from fishing vessels, and purseines is shot around the FAD, which increases a capture. Okay, fish including skipjack tuna and other species may congregate under the FADs. So untuk purseines ni biasanya ikan yang berkumpulan besar. Okay, yang berkumpulan besar dan primarily to catch fish for processing, untuk makanan yang dalam tin. Contohnya macam tuna, sardin, ikan mackerel. Okay, biasanya kita akan guna purseines ni lah. So next is gill netting. So gill netting is common fishing method used by commercial and artisanal fishermen of all the oceans and in some freshwater and estuaries areas. So gill nets are vertical panels of netting normally set in straight line. So fish may be caught by gill nets in three ways. Okay, ada tiga cara ikan ni tertangkap di gill net. Yang pertama, wedge, held by the mesh around the body. Second, gilled, okay, held by mesh slipping behind the opercula. Maksudnya dia terlekat dekat gill dia. And then number three is tangled, held by teeth, spines, maxillaries, or other protrusions without the body penetrating the mesh. So gill nets are so effective that their use is closely monitored and regulated by fisheries management and enforcement agencies. So mesh size as well as net length and depth are all closely regulated to reduce bycatch of non-target species. So gill nets have a high degree of risk of size selectivity. So this method is particularly has an extremely low incidence of catching non-target species. Compare dengan purseines tadi, usually when you caught fish in a large school of fish, akan ada non-target species. Contohnya seperti dolphin or shark or sometimes turtle. Jadi purseines tu risk dia tinggi. Untuk gill net, okay, this method is particularly extremely low lah untuk kita tangkap non-target species. So, and then we have hook and line. So a fishing line is a cord used or made for angling. Okay, the hook is usually attached to a fishing line, and the line is often attached to a fishing rod. So fishing rods are usually fitted with fishing reel that functions as mechanism for storing, retrieving, and paying out of the line. The hook itself can be dressed with bait. Kita guna umpan, which is designed to attract fish attention, and the bite indicator such as float is sometimes used. So angling is the principal method of sport fishing. So, but commercial fisheries also use angling methods. So in many parts of the world, size limits apply to certain species, meaning species below or above certain size must by law be released. So maksudnya bila kita tangkap ikan, there are certain size. Jadi jika terlalu kecil atau terlalu besar, kita akan lepaskan balik ke dalam laut lah. So we are going to go through multi-sensor satellite and fisheries data, statistical models, and marine GIS to detect habitat preferences of pelagic fishes. Okay? So introductions. Macam last week lecture kita dah cakap pasal remote sensing, and as we all know, the fishing ground are still determined by traditional hunting methods. So based on repeated experience as well as gathering information from fellow fishermen. So on the other hand, spatial structure and distributions of the pelagic fishes is not random. Okay, jadi taburan ikan ni dia bukan random. Okay, so they particularly vulnerable and change rapidly. Dia berubah dengan cepatnya bergantung kepada dynamic environmental factors and global changes resulting in distinct distributions and assemblages. So this complexity makes it difficult for the fishermen to determine fishing ground. Jadi, modern fish service methods have to some extent rendered unnecessary method for predicting fish distributions and availability on a short period of time. So there is not much effort required to monitor fish temperature, and the results are on entirely different scale of reliability and precision. So the existence of small pelagic fish is predictable. Okay, kita boleh predict through physical and biological indicators of the sea surface environment. So physical processes in the upper oceans influence biological processes and ultimately determine the distributions of pelagic fish. So the closely grouped physical and biological processes in marine ecosystem varies depending on various space and time scale, and it is represented by sea surface temperature dan chlorophyll. Okay, so advance in satellite remote sensing of the oceans have expanded our knowledge on oceanographic phenomenon at spatial and temporal scale. So previously kita tak tahu daripada ship dan buoy platform. Okay, tapi satellite remote sensing data used in oceanographic work is mainly from sea surface temperature, ocean color, and ocean altimetry. So application of GIS, remote sensing, image, and statistical models in fisheries oceanography are also widening our scope of marine studies in time and space. So GIS, widely developed for land-based applications, have grown to accommodate oceanographic work by incorporating functions that handle multiple dimensionality and dynamism of marine data. Okay, so analysis of remote sensing data and fisheries data under GIS environment have facilitated elucidations of fundamental relationship between marine biota and their oceanic environment. So dengan menggunakan GIS application serta geostatistical model, kita boleh provide a platform for integrating diverse forms of data to provide scientifically underpinned information for marine resources management. So objective of this study is to illustrate how remotely sensed information can be used to derive habitat indices for pelagic species such as contohnya yang kita akan guna mackerel. Okay, case study. Ini case study yang kita guna untuk Indian mackerel distributions and abundance. So seperti kita tahu, pelagic fish live and feed near the surface of the ocean's water and highly migratory and transboundary. So the Indian mackerel is one of the most abundant and commercially important small pelagic fisheries resources in Southeast Asia. So, Arcanagorta is highly migratory epipelagic fish. That means ikan ni dia berenang, okay, dan dia berhijrah. So, this species is a surface feeder which preys primarily on phytoplanktons and zooplanktons and school by size. Dia berenang migratory dalam satu kumpulan yang besar. Okay, the schooling indicates the presence of large number of fish which will be good fishing ground for fishing activity. Okay, lepas kita tahu ikan, background ikan tu, kita harus tahu juga study area. Okay, so data and methods. Okay, contoh study area yang kita ambil contohnya ada dua. Okay, yang pertama di archipelagic waters of Spomit. So one of the largest contributors of fisheries productions in Indonesia. So this area is located at the southern part of the Makassar Straits, which strongly influenced by the Asian Australian monsoon. And this area is also the main pathway of mean flow between the Pacific Oceans and the Indian Ocean, known as the Indonesian Through Flow atau ITF. So interaction between the monsoon and the ITF affects the current circulation system, heat transport, tidal mixing, wind-induced upwelling and downwelling, the environmental variable of chlorophyll concentration, SST, and salinity of the area. So in Malaysia, study case the Malaysia Exclusive Economic Zone, EEZ, of South China Sea. So the EEZ is part of the South China Sea and it is influenced by East Asian monsoon system. So the monsoon play a great role in the seasonal monsoon that occur annually in this area. Okay, which is southwest monsoon, northeast monsoon, and transition monsoon. And this monsoon characteristic influence the oceanographic processes, thereby affecting fish captured and landing in these regions. So, untuk data GIS. Okay, data GIS ada dua. Okay, there's two types of data, which is vector and raster. Okay, so vector data are data types that represent real world features as point. Contohnya fish locations atau building. And then we have lines as contour or road, or polygons as marine protected area or car park. And then kita ada raster data, which represent real world features as grids. Okay, which store values that used to interpret the real world features. Contohnya SSH, SST, chlorophyll, dan kedua-dua data ni berguna dalam GIS in different scenarios. Okay, it is important to point out the differences so as to make their usage in subsequent sections convenient. Okay, contoh data yang seperti di kanan tu lah, di kiri. Okay. Okay, so image processing and GIS software. So there are several types of image processing and GIS software available that can be used to analyze remotely sensed oceanographic data. Some are commercial, while others can be downloaded free from the internet. So ArcGIS, AirDAS Imagine, and Idrisi are some of the commercially available software capable of working with remotely sensed imagery. On the other hand, the generic mapping tools or GMT, CDAS, and GRASS are freely available for download from the internet. So gambar on the right show schematic flows of methods and tools used in the analysis. Jadi first kali kita perlu ada data perikanan. Contoh data perikanan mackerel pada tahun 2008 hingga 2010. Dan kita ada data remote sensing. Okay, kita download dan kita extract nilai dia menggunakan GIS. Kita letak dalam GIS, kita overlay, and then that data we import into contohnya R software, and we do the modeling analysis. So we got the distributions map. Okay, kita dapat taburan ditentukan. Jadi daripada situ kita akan keluarkan satu map which indeks kesesuaian dikenal pasti dan pemetaan habitat di GIS. So, untuk fisheries data. Fisheries data are useful mainly for indicating occurrence and abundance of a species in a certain area. Okay, fisheries data and satellite-based chlorophyll and SST oceanography data for a certain period of time were used in this case study. So the data were comprised of latitude, longitude, position, catch per unit effort. Okay, by mapping this data onto remotely sensed image at corresponding time scale, they can reveal the condition under which catches are made. So contoh macam dalam gambar tu, it shows that we have spatial informations, longitude, latitude, and then we have temporal informations, year, month, we have day, and then we have fisheries informations such as catch per unit effort, and kita ada environmental information derived from remote sensing image, SST, chlorophyll, and SSH. So data-data yang kita ada ni, okay, dia berguna for modeling the habitat conditions of the species. Okay, they were also used to make generalized additive model from which ranges of habitat variable important for mackerel habitat were derived. Okay, for remotely sensed environmental data. So, contoh kita guna 3 data, 3 types of data, SSH, chlorophyll, and SST. So, each of these variables can be important indicators for the habitat of pelagic species. Okay, there are different ways of analyzing satellite datasets given their spatial and temporal resolutions. Considering the temporal scale, one way would be to use the individual satellite passes for a certain variable, which can differ from hours to days depending on the repeat cycle. Another way would be to work with temporally average data, either daily, 3 days, 7 days, 8 days or monthly depending on the objective or the data. Contohnya data, kalau kita tak guna data harian, kita boleh guna data mingguan which kita dah averagekan data tu untuk 7 hari atau sebulan bergantung kepada objektif yang kita nak capai. Okay, so data averaging is commonly used to minimize instances of missing data due to weather conditions seperti clouds of rain or instrument malfunctions. Kalau kita guna data harian, kadang-kadang ada data yang tak ada. Usually kalau yang warna putih tu menunjukkan no data available. So usually kalau kita guna data yang average 3 hari atau 7 hari, 8 hari, okay, data tu akan penuh lah. So contoh, okay, if we use remotely sensed graded SST and chlorophyll were derived from MODIS measurements, kita guna daily level 1 kilometer SST and chlorophyll were obtained from the Ocean Color website. Okay, kita boleh dapat data ni daripada Ocean Color website and then menggunakan CDAS version untuk extract and process the satellite data. So the data were then subset accordingly to the study area using ERDAS Imagine version 10. Untuk SSH, kita guna data daily which was downloaded from NOAA Coastwatch. The data was derived from Aviso with resolutions of 0.25 pixel. So sebab gambar SSH dengan SST dengan chlorophyll tak sama, jadi we have to resampling the image. So resampling the image resolution is an important step, especially in cases where the data sets in use have different spatial resolutions. So harmonizing the resolutions before analyzing the data further ensure that the pixel values for all images have the same dimensions. Okay. So thermal and ocean color front mesoscale phenomena such as warm and cold core eddies and ocean currents are key features that determine the distributions of pelagic fish. Okay, since the advent of ocean satellite remote sensing, it is possible to monitor the development of these fishes at relatively large spatial scale and hence as assess their effect on fish habitat. So information from such studies has had applications in operational fisheries oceanography and marine resources conservation. So to enhance our understanding of satellite images interpretation in relation to fish ecology, we will first consider one set of three images, iaitu SST, chlorophyll and SSH, each of which is overlaid with daily resolve fishing location. So kita akan overlay data SST, chlorophyll dan SSH di bawah fishing location. Okay. Contoh macam ni. Kalau kita tengok gambar SST tu yang bawah sekali, kita color codedkan dia from blue to red. Okay, kalau kita nampak titik merah itu adalah fishing location. Okay, so bila kita color coded, the red represent warm waters while blue shows cold water or lower temperature. Jadi yang titik-titik fishing location tu kita nampak dia berada di kawasan yang berwarna biru. Okay, so the same fishing locations are overlaid on chlorophyll image. So chlorophyll yang atas tu, blue areas of this image show low chlorophyll waters, while the green to red color represent relatively high chlorophyll waters. So dari situ kita nampak fishing location tu berada di kawasan yang berwarna hijau. Hijau ke kuning macam tu kan. So okay, fishing locations also overlaid on SSH image. Okay, data SSH ni useful in showing mesoscale variability in the oceans. So these involve the distributions of eddies and surface currents. So in this image, area with positive anomalies are shown as green to red, which are likely to indicate presence of warm core eddy. So dark blue to purple areas indicate areas with negative anomaly, which represent cool core eddies. So kita nampak fishing location tu dia overlay dengan SSH, dia berada di kawasan yang berwarna biru ke purple. Okay, which represent cool core eddies. So untuk statistical analysis, kita ambil data sampel daripada satellite image, kita compile dalam satu database that describe the conditions where fishing is taking place. So data from such database can be used to generate models. Kita buat modeling that provide more information on the habitat of the species in questions. So different type of models can be applied depending on the objective of the work. So fish distributions and oceanographic parameters are shown to have a non-linear relationship. Untuk ikan, setiap spesies ikan mempunyai their preferred optimum range. Okay, so optimum range of chlorophyll and SST will be suitable for the fish. Dan kalau SSH, chlorophyll and SST are less or higher than the optimal range, okay, it will be demonstrated as less suitable. Okay, so statistical modeling methods has been used in describing the relationship between individual species distributions and oceanographic characteristic of its environment. Contoh yang selalu guna adalah generalized linear model and generalized additive model. Tapi there are some of ecological modeling habitat yang menggunakan machine learning seperti maxent, random forest dan juga boosted regression tree. So, lepas kita guna statistical analysis dan kita produce the predictions of fishing ground, kita perlu ada accuracy assessment. Okay, so the accuracy assessment of the potential fishing ground maps was carried out using kappa statistic. So, it was performed by comparing the actual catch with the potential predicted area based on the statistical analysis. So prediction accuracy evaluations was carried out using the predictive deviance and the area under the receiver operator characteristic ROC curve. So area under curve atau AUC is the common statistical test of ROC, which is expressed as the proportions of the total area of the unit square defined by the false positive and true positive axis. So in general, a forecasting model with AUC larger than 0.75 is considered to be useful. Okay, so ini hasil, okay, hasil determinations of mackerel fishing ground. So from Nudin, Indian mackerel in the archipelagic waters, to determine relationship between Arcana-Gupta distributions with oceanographic parameters, dia menggunakan dua, SST dan chlorophyll, and to identify the potential fishing ground in the archipelagic waters of Spomate throughout 2008 to 2009. So dia guna method MODIS, SST dan chlorophyll. Statistical analysis yang diguna adalah GLM dan JAM. So major findings didapati the distributions of Arcana-Gupta was significantly associated with the preferred range of chlorophyll at 0.3 to 0.4 milligram and SST at 30 to 31 degrees Celsius. So the potential fishing ground map show that area with high potential catch were located near the coast to offshore with acceptable level of map accuracy at 83.3% with kappa value at 0.70. So another study, Indian mackerel in Malaysia EEZ of South China Sea. The objective of this study are to model the influence of environmental variable. Di sini guna tiga, SST, chlorophyll and SSH on potential fishing ground of Arcana-Gupta from 2008 to 2010 in Malaysia EEZ of South China Sea. So MODIS, SST and MODIS chlorophyll. For SSH menggunakan data satellite from Aviso, and we're using BRT for statistical analysis. So the result indicated that potential fishing ground were closely associated with SSH followed by SST and chlorophyll. So the performance of BRT model indicates acceptable fishing ground predictions accuracy at 0.75. So seasonal variability in fishing grounds was related to favorable environmental conditions of SSH 1.1 to 1.3 meter, SST 29 to 32 degrees, and chlorophyll at 0.3 to 0.6 milligram. So di sini kita dapat conclude yang ikan mackerel ni dia suka berada di kawasan sea surface temperature antara 29 ke 32. Within that range. So probably kalau temperature lower than that or higher than that, ikan ni akan berenang pergi ke tempat lain lah. Okay, dan chlorophyll yang berada pada 0.3 to 0.6. Okay. So this is contoh map ya. Contoh map yang di kiri tu potential fishing ground map of Arcana-Gupta in the archipelagic waters on 29 April and 4 May 2008 on your left panel, and on 22 May and 23 June of 2009 on the right panel. So kalau kita nampak color bawah tu 60 kilometer 60 kilogram show red color. That means color merah menunjukkan kawasan potential catch yang tinggi, di mana warna biru menunjukkan potential catch yang kurang. So if you see the round shape and the right segitiga shape tu menunjukkan actual catch. Jadi actual catch dengan predicted catch sama. Contohnya macam kalau bulat tu lebih daripada 12 kilogram, dia sepatutnya berada pada warna merah. Okay. Gambar yang di kanan juga sama. Predicted probability of fishing ground of Arcana-Gupta in EEZ showed in the maps. Data dua-dua ni kita menggunakan data daily. Okay, that's why you see ada warna merah, warna putih tu blank, white areas indicates no data. Unavailability of satellite data coverage. So kalau digambarkan kiri tu, kalau predicted fishing ground more than 200 kilogram, dia akan berada di kawasan kawasan kuning ke merah. So as you see, the yellow area usually at the coast of Peninsular Malaysia. And the actual fishing points yang bentuk star tu, if catch more than 200 kilogram akan berada pada warna kuning dan merah. Okay. So, apa conclusion daripada study tadi? So we can see that changes in oceanographic conditions influence vertical and horizontal movement of pelagic species. So fish species akan respond differently to changes according to their habitat preferences, resulting in distinct distributions and assemblages. So variability in ocean physical processes also plays an important role in enhancing ocean productivity and creating availability of forage zone, which results in seasonal variations of fish aggregations. So study showed that variability in oceanographic conditions influence aggregation area of Arcanacuta specially and temporally. So integrations of satellite data, GIS, and statistical analysis combined with in situ observation related to fish abundance are the most effective ways to manage fisheries at sustainable levels. So that's all for today. Thank you.
Thank you very much, Dr. Yeni.
Thank you.
If you don't mind, maybe you can share your PDF file
Okay.
as you did last week. Thank you very much.
Thank
So,
you.
student, we have a time for
15
question and
minutes.
discussion. So please feel free if you have question or maybe comment or anything you want to ask to Dr. Yeni, please feel free, student. Okay, is there any? Okay, Rafif Adi. Thank you very much, Rafif Adi. You can directly ask to Dr. Yeni.
Yes.
Go on, Rafif.
I want to ask, what is a difference between GLM and GIM in the application?
Again? Sorry.
What is the difference between GLM and GAM in the
Okay.
application?
Generalized linear model and generalized additive model. What is different? I don't use GLM, but it's a pengiraan tu yang membezakan GLM dan GAM. Tapi biasanya GAM tu linear model, so GAM is additive model. So usually people are using generalized additive model untuk mendapatkan that habitat punya preferences, dan setiap statistical analysis akan menghasilkan different objektif lah. Dia bergantung kepada objektif tu nak dapatkan apa. Jadi kita akan menggunakan statistical analysis yang sesuai dengan data tu. Tak semua data kita boleh guna GLM dan JM. Macam tu lah.
Okay, thank you very much. Rafif, that's clear?
Thank you, Miss.
Okay, thank you, Rafif.
Thank you, Rafif. Student, please feel free. Anything else? Okay, students. Dr. Yeni, actually, when we dealing with the satellite images, which kind of satellites that commonly student in your university use for their research in the fisheries oceanography?
I personally use Modis Aqua.
Okay. Okay. Is there any specific reason why Modis? I mean,
because
we
it's
know,
easy
there are a lot.
to download, maybe.
Oh yeah.
Yeah.
Okay, students. Is there any other question or discussion? You can use bahasa
Yes.
Indonesia or Malay. I think Dr. Yenis understand our language. Please, Debri Sabrina maybe.
If I speak in Malay, do you understand? Faham ke?
Yeah, yeah.
Faham. Faham.
Paham.
Okay.
Maulana paham, Maulana.
Faham.
Dr. Yani,
Excuse me.
yeah, Lutfia.
I want to ask to Dr. Yeni,
Mhm.
what is the maximum depth that satellite imagery can work? Thank you.
Maximum depth. Maximum. I'm not sure. I never worked with depth before. But I think probably 200 meters can go, Pak Abu. How?
Yeah. This is something like just depend on the penetration of the light,
Yeah.
yeah, of the sunlight, because the sensor of the satellites catch the reflectance
Mm.
energy. So maybe that's depend on the penetration of the sunlight and maybe the in bahasa we call by kekeruhan ya,
Oh, okay.
turbidity, water turbidity.
Turbidity, yes.
Uh, Thank you, Lutfia. How
Thank
about
you, Lupia.
the application of satellites to identify the benthic object or maybe demersal fish?
Mm-hmm.
Do you also dealing with that kind of species, Dr. Yeni? I mean, for the
Um,
demersal fish.
I'm not sure about dimensal a benthic organism. Okay,
Mhm.
but maybe they have. Sekali dengan corals also I think have spatial distributions of coral using remote sensing.
Yeah.
Yeah. For benthic, I'm not sure because I haven't deal with benthic organism before. I use fish.
Yeah.
But
And
in
also,
my master study, I use crabs, but the effect of ocean acidification on crabs. But
oh,
it's not on marine satellite. But I
yeah.
study crab on effect of ocean acidification on crab. Yeah.
Yeah. So there is something like behavior of the crabs,
Yes.
or
Yeah. Let's say if the temperature rises and the oceans become more acidic, what will be the effect on the crabs physiology
of
and
physiology,
energy allocations? Yeah, something like that. Yeah.
and also the migration of the crabs.
Yeah. Let's say if we put the crab in lab and we increase the temperature and the salinity and the pH, so the
Mm.
crab will have to adapt to the conditions. They have to use more energy to adapt, so resulting in their lipids concentrations and their carbohydrate concentrations akan kurang because they have to use more energy untuk berlawan dengan temperature yang tinggi tu. Yeah, something like that. Yeah.
Yeah. Talking about the ocean remote sensing, commonly here in Indonesia, mostly the research on this part mostly is focusing on pelagic fish.
Yes.
So
Pelagic fish.
I don't know about the similar research in Malaysia. Is there any other research maybe from Pak Eko? You know Pak Eko, right?
Pak Eko, from where?
Uh, me, Actually, he is Indonesian, but now he's dealing with
Oh,
some.
I think I know. Yes, yes, yes,
Yeah,
yes.
yeah, yeah.
Yeah, yes.
Jadi he's
He
dealing with.
studied economy, right?
Yeah,
Economy.
yeah, yeah,
Yes, okay. Yeah,
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 yeah.
yeah. Yeah.
Um, I don't know the research in this area in Malaysia, but is there any research relating to satellite, the application of satellite remote sensing, but focusing on the demersal fish? Because
Demersal
commonly,
fish.
yeah, commonly here in Indonesia, they only focus on pelagic fish
Yeah,
like
yeah,
mackerel, sardine, like
yeah. Tuna. Yeah.
Tuna, like Pak Jainuddin
Yeah, yeah, yeah.
or he's dealing with pelagic fish, but very rare. Some researcher that focusing on demersal fish, maybe like um, Napoleon fish, or maybe
Okay.
some fish associated with coral reef
Yeah.
ecosystem. How
Um,
how about that?
I'm not aware of that kind of study in Malaysia. I think it's same with Indonesia. But in my lab, my supervisor do marine remote sensing in mangrove, mangrove,
No.
mangrove ecosystem, including firefly.
Yeah, yeah.
So yeah, not benthic or demersal fish. So it's either mangrove ecosystem or pelagic fishes.
Mhm.
Yeah.
Okay. Student, is there any question? Maulana. Yeah, please, Maulana.
Good afternoon, Miss.
Yeah, good afternoon.
I have a question for you. What if oceanographic conditions are still global warming? Can we still be used to determine fishing ground using satellite with SST and chlorophyll data?
Mm-hmm.
Hmm,
Macam
thank
mana?
you.
Lagi
Ah.
sekali, Maulana, again the question.
Uh, gimana?
Guna bahasa lah, bahasa.
Bahasa lah, bahasa.
Ya,
Yang penting jangan pakai bahasa Jawa, Maulana.
in
Bahasa
bahasa
Indonesia. Ya, ya,
Okay.
bahasa Indonesia.
Intinya bagaimana jika kita menggunakan apa? Bagaimana jika kondisi oceanografi itu dalam keadaan global warming?
Okay.
Apakah kita masih bisa menggunakan apa data citra satelit atau satelit itu untuk menentukan daerah fishing ground?
Okay, betul. Okay, faham. Okay. boleh. So from that, contohnya macam kita dah determine fishing ground kan. We already determine the fishing ground. Okay, let's say if we want to predict what happen if the temperature increase. Contohnya temperature predicted climate change increase by 1.5 degree or 2.8 or 3.3. So what's going to happen to the fishing ground? Okay, so we can use that predictions using marine remote sensing to predict what happens. So in studies, they showed that in climate change, in occurrence of climate change, so fishing ground tu akan berubah juga. Contohnya, kalau ikan tu usually untuk normal conditions dia ada di coastal, di tepi pantai. So nanti makin lama makin panas, so tepi pantai akan lebih panas kan. So ikan itu akan berenang ke kawasan yang lebih jauh. Okay, they will migrate, especially pelagic fish, since they can swim very well. Okay, dia berenang, jadi dia akan berenang menjauhi kawasan yang panas tu. So maybe in future we have no longer stock of pelagic fish due to climate change. Okay, ikan tu akan berenang ke kawasan yang lebih sejuk, yang sesuai dengan optimal range dia tadi yang kita kira tadi kan. Contohnya dia sesuai dengan 29 ke 30 darjah Celsius. Tapi di coastal area temperature dah naik dari 32 atau 33. Jadi terlalu panas untuk ikan tu. Ikan tu akan berenang ke kawasan yang lebih sejuk. Yeah. We can use it to model climate change. Yes.
Wow. So you mean we also have to collect for the climate data set instead
say,
of oceanographic data?
Okay. Let's say in my study, I use SST data, let's say, and then I increase the temperature of the satellite images to, let's say, 1.5, and then let's see what happened. Something like that. So yes, I use satellite remote sensing data to predict climate change.
Maulana?
Faham tak?
Maulana piye?
Faham tak Maulana?
I'm
Faham tak?
thank you for the question.
Okay.
Yeah, thank you, Maulana. This is something just related to the Maulana's question. I think. Actually, how many years or temporally, how many years we can use the oceanographic data and also the fisheries data in order to make some model to predict the habitat of certain kind of species.
Okay, I think
We need more than 10 years or maybe only 5 years is enough.
I'm not sure, but for my study, I used 2008 to 2010 data. So I think that will be good enough. And we have satellite data every day. So until today, usually we can already download the data today, right? Yeah.
Yeah. Do you know Himawari satellite data, Dr. Yeni? Nowadays, that kind of satellites being familiar with our student, and in previous maybe 2 or 3 years ago, they apply MODIS data for their research in oceanographic, in fisheries oceanographic, but nowadays they start to use a new meteorological data, satellite data from Japan. Himawari satellites. They try to use the Himawari satellite to produce sea surface temperature and also maybe sea surface chlorophyll as two oceanographic parameters for make some model to predict the suitability habitat of pelagic fish.
Is that that satellite data can in our area or only in Japan?
I think also in our area.
Or the satellite covers also in Southeast Asia.
Yeah, just like a MODIS data, but the spatial resolution is higher than MODIS, I think. Maybe when we apply MODIS for the monthly, the resolution is around 4 kilometers. 4
kilometers, yeah.
But when we apply Himawari satellites, maybe the resolution
you can get 1 kilometer.
Yeah, 1 kilometer.
For monthly data.
Yeah, for the monthly data.
Okay.
And free actually.
And it's free. Okay, maybe I can use that satellite later.
Yeah, just like ocean color in
I see. Okay.
Yeah.
Himawari.
Himawari, yeah. Himawari. Shinchan's little sister.
Himawari Shinchan.
Is there any other question, student? We have now 33 students right now from the class of P03. Is there any other question? Please we still have time.
For next week class,
Yeah.
application on fisheries oceanography, can we
Yeah.
talk about current issues in oceanography? Because I
Yeah.
think I already cover application of
Yeah. Yeah.
emergency.
Yeah.
Yeah.
Yeah. Yeah.
Yeah.
Please feel free,
Yeah.
Dr. Yani.
Okay.
Yes.
All right. We
That's
are
good.
going to talk about current issues in oceanography.
Yeah. Yeah. Yeah.
So for next week
Very
class,
good.
inshallah. Okay.
So, thank you very much.
Okay.
Student, please feel free if you want to ask something to Dr. Yeni. Okay, Zikri Hasnur, raised hand, please. Zikri.
Okay, thank you, sir. I want to ask about information about potential fishing gear, fishing
Okay.
area.
Okay.
How the Malaysian fishermen get the information on now potential fishing areas using SSD, CHL, and SSH.
Okay.
Yes.
Nowadays.
How do Malaysian fishermen get information?
Okay. I think same like Indonesian also. They use maybe echo sounder or and then dekat atas kapal also can show the SST. But if satellite remote sensing on ships or I'm not sure. Okay, but I think a traditional method they use echo sounder and they can detect SST through the ship, right? Yeah. So I think it's not that advanced yet.
Yeah.
Compared to Japan or other countries, yeah.
Yeah. Dr. Yeni, is in our country, in Indonesia, our ministry, the Minister of Fisheries and Marine Affairs, in every 2 weeks they produce a map of fishing ground, a map
Okay.
of potential fishing ground. So we will distribute that kind of map to
Oh,
the academician, to the local fishermen, and also for the public. So we can download it freely in their website.
oh,
So we know if we want to catch a certain kind of species, in which area we have to go. Is there any kind of program like that
okay.
in Malaysia's
Yes,
government?
in Malaysia, in UMT, I think in Terengganu, we have one for sports fishing. Let's say for tourism, right? Okay, contohnya I want to go fishing. So I want to go to that place. So nelayan akan ada data di mana ikan ada. So tak adalah pergi tapi nak pergi memancing tapi ikan tak ada. That's for recreational. That one is I'm aware. In UMT, the lecturer ada satu apps yang dipanggil for recreational fisheries. That means if you want to go to catch squid or fish, dia akan ada satu apps menunjukkan kawasan yang kita boleh pancing ikan. For recreational, not for commercial. Yeah.
Oh, so there is no for commercial one, right?
Yeah, not for the commercial one, but for recreational one. Untuk tourism, for tourism. Yeah. For sports fishing.
Okay, thank you very much, Dr. Yeni. I think the time is coming.
Okay.
Student, is there any other question? I think there is no question. I think students looks like very tired today. They have a
You
class
had
from
a long day.
they have a class from dusk till dawn, I think.
Oh.
So thank you very much, Dr. Yeni. Thank you again for giving us the lecture today for the
Thank
topic of
you.
data and method in fisheries oceanography. See you next week. On
Okay.
see you tomorrow.
Tomorrow,
Okay.
yes, tomorrow.
Yeah, tomorrow you will have the same topic but different participants, so
Okay.
different class. But student for the class P03 today, if you want to join again, if you have free time tomorrow, please join again. The topic is same, but the participant actually for another class, but you can join too. Thank you very much, student. Keep
Thank
healthy.
you.
Thank you very much, Dr. Yeni.
Thank
Keep
you.
healthy.
Take care.